Now let's see how we can find the moment of the force. As we've discussed earlier, you need to use the cross product in this case. We have a force F which is equal to 3i plus 2j minus 4k, and it is applied at this point. We need to find the moment of the force about this point. Not this point, this point. So how do you do that? Well, let A be the point that the force is applied on, and let B be the point that we have to find the moment of the force about, right? So R is the vector that goes from B to A. So BA. So BA is basically equal to OA minus OB, OA being the position vector of A and B being the position vector of B, right? So that is equal to this. Now that you have this and you have F, you can simply find the moment required, and that is equal to R cross F, right? So you just find R cross F, and a reminder how to do that. You take I, you write it down, cancel out its column, cancel out its row. Now the remaining terms, these four terms, multiply the diagonals. So 0 into negative 4, that gives you 0, minus 2 into negative 1, that gives you plus 2, because minus minus is equal to plus. Then you write down j, negative j, because the second term is always negative, right? So you take this j, you write down minus j, cancel out its column, cancel out its row. Now the remaining four terms, multiply the diagonals. So negative 1 into negative 4 is equal to 4, and negative 1 into 3 is equal to negative 3, but since 4 minus negative 3, that will give you 4 plus 3, right? Now for the third term, again the same process as you did with I. So you write down positive k, you cancel out its column, you cancel out its row, you multiply minus 1 and 2, that gives you negative 2, and subtract from that 0 into 3, which is equal to 0. And now just compute the result, and that gives you 2i minus 7j minus 2k, and this is the required moment.